day, dear learners. This is Ramhale C. Gafud of Doña Magdalena H. Gafud High School. And for today, this video lesson is all about determining the conditions under which lines and segments are parallel or perpendicular. Let us start with the parallel postulate. Given a point and a line that containing it, there is exactly one line through the given point parallel to the given line. So here is a picture of parallel lines. How can we say that the lines are parallel? First, the two lines are parallel if and only if they are coplanar and they do not intersect. Coplanar means they are at the same plane. And then, this is the symbol for parallel lines. The following are examples of parallel lines. We have M is parallel to N, A is parallel to B, and X is parallel to Y. Parallelism is not only limited to lines, but in segments as well. Here, the two segments are parallel if and only if the lines containing them are also parallel. Using this figure, we can say that segment KO is parallel to segment JN. Segment KO is also parallel to segment HL. And segment HL is also parallel to segment IM, while segment IM is parallel to segment JN. Let's have perpendicular postulate. It says that given a point and a line that contained in it, there is exactly one line through the given point perpendicular to the given line. This is the symbol used for perpendicular lines. When we can say that the lines are perpendicular, the lines are perpendicular if they form right angles. If we have line M, which intersects to line N at point A, there is a right angle created, meaning M is perpendicular to N. Let's have the theorems and the postulates for perpendicular and parallel lines. We begin with corresponding angle congruent parallel postulate. Given two lines cut by a transversal, if corresponding angles are congruent, then the two lines are also parallel. In this figure, we can see that angle A is congruent to angle E because they are corresponding angles. If these two corresponding angles are congruent, then the conclusion will be M is parallel to N. For the next one, we have the alternate interior angle congruent parallel theorem. Given two lines cut by a transversal, if alternate interior angles are congruent, then the two lines are parallel. Given this figure, we can say that angle D is congruent to angle F because they are alternate interior angles. The conclusion will be M is parallel to N since the alternate interior angles are congruent. Third one, the same side interior angle supplementary theorem. Given two lines cut by a transversal, if the same side interior angles are supplementary, then the two lines are parallel. With this figure, we can say that angle D and angle E are supplementary since they are same side interior angles. Our conclusion will be that line M is parallel to N since the two same-side interior angles are supplementary. Next, the alternate interior corresponding angle theorem. Given two lines cut by a transversal, if alternate interior angles are congruent, then the corresponding angles are congruent. Using this figure, we can say that angle A is congruent to angle B since they are alternate interior angles. Using the theorem, we can conclude that angle B is congruent to angle C since they are corresponding angles. Now let's proceed with three parallel lines theorem. This theorem gives us the idea that in a plane, if two lines are both parallel to the third line, then they are also parallel. Now let us consider this example. Using the figure, if M is parallel to L and N is parallel to L, then our conclusion will be that M is parallel to N using the parallel lines theorem. And the last one, let's talk about the perpendicular to a third line theorem. This defines that if two coplanar lines are perpendicular to the third line, then they are parallel to each other. Take a look at the figure. In this figure, line 1 is perpendicular to T and line 2 is perpendicular to T. Therefore, we can say that line 1 is parallel to line 2. Now, let us have different figures or examples and we will answer them which theorem or postulate is being used. In this example, we have angle 1 and angle 2. The relationship between these two angles is that they are alternate interior. So, what theorem is to be used? Correct. The correct theorem to be used is the alternate interior congruent parallel theorem. Now, in this figure, what is the relationship between angle 1 and angle 2? Any idea? Great! Angle 1 and angle 2 are corresponding angles. So, we will use the corresponding angle congruent parallel postulate. To tell whether line M is parallel to line N, what possible postulate or theorem is to be applied in dealing with the relationship of angle 1 and angle 2? Any wild guess? Great! Here, they are same-side interior angles. So the theorem being used in this example is same-side interior angle supplementary theorem. Now, let's consider this example. In the figure, we have line M, line N, and line L. Now, what possible postulate or theorem we can use or we can apply so that M, N, and L are parallel? Correct. The correct answer is the three parallel lines theorem. Now, take a look with this example. What can you see? Great. You can see square-like illustrations in the figure. What does it indicate? Yes, correct. It indicates us that the angles being illustrated are right angles. So, if there are right angles, what does it imply? Awesome! It implies that the lines form right angles and meaning they are perpendicular. So in here, we will use the perpendicular to a third line theorem. Next, we will use this figure. If the measurement of angle 6 is 80 and the measurement of angle 8 is also 80, what is the relationship that underlies angle 6 and angle 8? Correct. They are corresponding angles. So, the postulate or theorem being used is corresponding angle congruent parallel postulate. Using the same figure, the measurement of angle 2 is 80 and the measurement of angle 3 is 100. What is the theorem or postulate being used here? Amazing! It is the same side interior angle supplementary theorem. Now, if measure of angle 3 is 115 degrees and the measurement of angle 7 is 115, what do you think is the postulate or theorem to be applied in this example? Great job! The postulate or theorem being used is the alternate interior angle congruent parallel theorem. Now, if measure of angle 2 is 84 and the measurement of angle 6 is 84, what is the postulate or theorem that we can use to prove the relationship of the two angles? Wow, that's great! It is the alternate interior angle congruent parallel theorem. Also, how about if angle 6 is 75 and the measurement of angle 7 is 105? The answer is the same side interior angle supplementary theorem. Now, we will use this figure as an example. If the measurement of angle Q is 3x minus 10 and the measurement of angle S is 2x plus 45, we will find for the value of x. First, we need to identify the relationship of angle Q and S. They are corresponding angles, right? If they are corresponding angles, we can say that the measurement of angle Q is equal to the measurement of angle S. Then we will substitute the measurements for angle Q, which is 3x minus 10, and for angle S is 2x plus 45. We will use the left and the right side. We will start with 3x and we will collect all the terms with variables on the left side and all the constant on the right side. 3x is at the correct position, so we'll just copy. Next, we have negative 10 and we need to transpose negative 10 to the right side so it will become positive. And then we have 2x. We need to transpose it. It will become negative 2x. And then the last one, which is positive 45, it is constant, so it is at the correct position. We will just copy it. Then, we will simplify 3x minus 2x, and that is x. And 10 plus 45 is equal to 55. So, the value of x here is 55. Let us now solve the measurement of angle Q. Take note that measure of angle Q is equal to 3x minus 10. And from our previous solution, x is equal to 55. So we need to substitute that 55 as the value of x. So we'll have measure of angle Q is equal to 3 multiplied by 55 minus 10. Multiply that, it will give you 165, and subtract that with 10. Therefore, the measure of angle Q is 155. Now, let us consider this example still, and take note that Q is already 155. We need to solve for the value or the measure of angle S. Take note that measure of angle X is equal to 2x plus 45. Substitute X as 55, so it will give you that 2 multiplied by 55 plus 45. Multiply 55 with 2, it will give you 110. Add it to 45 to give you the measurement of angle S. And now we will have 155. So, it will give you the idea that measure of angle Q is equal to measure of angle S since they are corresponding angles. Now, we can solve for the measurement of angle R. We can say that angle R and angle S are supplementary since they are same side interior angles. So the measurement of angle R is equal to 180 less the measurement of angle S. And since measure of angle S is provided, that is 155, so we need to subtract that to 180. It will give you the measurement of angle R, which is now 25. How about the measurement of angle T? The measurement of angle T is also 25. Why? It is because it corresponds to angle R, and angle R is 25 degrees. So therefore, the measurement of angle T is 25. Now, let us solve for the measurement of angle U. Angle U is also 25 since angle U and angle T are alternate exterior angles. And since they are alternate exterior angles, they are also corresponding, which means their measures are congruent or equal. Next, let's have measurement of angle V. Angle V is also 155 because angle V and angle S are alternate interior angles. So if they are alternate interior angles, their measures are congruent or equal. How about the measurement of angle W? Angle W is 25 degrees since it is alternate interior with angle R. So therefore, W is 25. For this example, we need to find for the measure of angle Z. Measure of angle Z is equal to measure of angle S. Why? Yes, it is correct. Measure of angle Z is equal to measure of angle S is equal or true because Z and S are vertical angles. So therefore, when we say that angles are vertical, that means their measures should be equal. Therefore, measure of angle Z is 155. But if we are to consider the different theorems and postulates stated on our lesson, we can say that measure of angle Z is also equal with the measure of angle V since they are corresponding angles. And if they are corresponding, they are also congruent. Still, it will give you the same answer as 155. Now, let us solve this one. If measure of angle T is 5x plus 17 and the measure of angle Z is equal to 3x minus 5, find for the value of x. Take note that T and Z forms a linear pair. And if they are a linear pair, if we are going to add their values, it will give us 180 because linear pairs are supplementary. So, measure of angle T plus measure of angle Z is equal to 180. We need to substitute the values. Measure of angle T is 5x plus 17 and measure of angle Z is 3x minus 5. Add the two, it will give you 180. So, what will we do next is to combine similar terms. We need to add 5x and 3x, then it will give you 8x. And subtract 17 with negative 5, it will give you positive 12. So, I'll just copy 180. Now, we need to transpose positive 12 to the left side, or right side rather, of the equation, because on the right side should all be constants. So that will give you 8x is equal to 180 minus 12. And then, subtract 12 with 180, that is 168. So, in order for us to find for the value of x, we need to divide both sides of the equation by 8, and it will give us x is equal to 21. There you have it, dear learners. We have discussed the lesson in determining the conditions under which lines and segments are parallel or perpendicular. This is from Hales C. Gafud of Doña Magdalena H. Gafud High School saying, sa Project MTOP, sagot kita.